Okay, hello everyone, welcome to Master the Codes, and today we are going to take another question which has been asked in Amazon interviews, and that is burn the tree. So, what the question says is we have given a binary tree n of unique nodes where every node is unique, and a start node from where the tree will start to burn. Given that the start node will always exist in the tree, your task is to print the time in minutes that will take to burn the whole tree. It is given that it takes 1 minute for the fire to travel from the burning node to its adjacent nodes and burn down the adjacent node. Okay, so if you take this as an example, the given binary tree will look as okay, the data is given like this where -1 represents null and all the values except 1 are the nodes. So if I try to explain you what is exactly in the question, so if you are given a tree like this and say let's say the burning time or the burn node is 3. In 1 minute you will go from 3 to 1, 4 and 5. Okay? Then from 1 you will go to 2 and 3. Since 3 is already burned you will go to 2. So if you look at it, it will take 2 minutes and extra plus 1, 3 minutes to burn the entire tree. So also one thing clearly you can see over here that we have node 3 which is not the root. So the node given to us may not be root itself. It can be any other node, it can be a leaf node, it can be an intermediate node, or it can be a root node, but it will not necessarily be a root node. So from 3 given in a tree, we know a tree is a directed graph where from we can go from root to child, but from child to root or parent is not possible. So if you look at this, from 3 we can go to 4 and 5, but how to trace back to 1? Because if you see in the question, from 3 we are going to 1 and then we are going to 2. So how to reach the parent? In that case, we will assign parents to each node and create a parent array. This is our parent array. Now how we will create? We can use a DFS technique in which in this DFS we will pass the root, the parent and the tree node itself, or you can simply pass the root and the parent, right? So if you look at this, if I explain it more visually, your DFS of 1 we will give it as -1. Okay, then we will go to the subchilds, the DFS of 2 where the root is 2 and parent is 1. Similarly, DFS of 3 where root is 3 and parent is 1. Clearly you can see there is a relationship between these values. The first value of the parent is the second value of the child. Also, similarly you can see over here DFS of 4 will be 3 and DFS of 5 will be 3. And so the second values are the first and the first value of the parent are same. So that is how you will be able to construct the tree. Okay, so you will use DFS to store the parents in the array. So if you look over here, the root of 1 has a parent of -1, 2 and 3 have a parent of 1 and 4 and 5 have a parent of 3. Then how can we spread the fire? We will start from the node, the burning node which is given to us, and we will spread the fire using BFS, right? So what will happen in this particular simulation, that is we will start from burn node 3, we will move to the left, the right and the parent if not burned, if not burnt. If any of the 3 is not burned, we'll add it into the queue and mark it as burnt. So from 3 we'll go to 1, 4 and 5. Okay, then from this 4 and 5 we can go to 3, but since 3 is already burnt we'll not go there. From 1 we'll go to 2 and 3. Also 3 is already burned, we'll not go to 3, we'll simply go to 2. So we will reach the nodes via left, right and parent. Okay, and if you look at it, the max time to burn will be 2 minus 1, that is 3, because 0, 1 and 2. And if you look at it, the time complexity for creating the parent array is order of n, and similarly the time complexity for burning the tree is order of n. I'll provide the code down in the link of the description where you can access the code and try to understand it. If you find any difficulties, please put it down in the comment section and I'll be there to assist you. So this is the main logic where you can solve this particular question. It requires a DFS traversal for calculating the parents, a BFS traversal for burning the tree, and a little bit of tree properties of left, right, and parent. And in that way, you will be able to solve this particular question. In case you have any doubts, please feel free to ask, and I will be providing this particular notes, all these notes in the description down below for you to access them and have a look at them. So please don't forget to like, share, and subscribe to the channel and hit the bell icon for more notifications. Until then, bye bye.